See, first we start, everyone silence. First we started with basic terms. Okay, then next we have started discussing about thermodynamic properties like intensive properties, extensive property. So how can we identify intensive and extensive property? If it is mass dependent, extensive. Mass independent. Have you tried questions from the module? Like first 5-6 questions are based on intensive extensive properties only. Once check that, it will give you whether you have followed the class or not. From that questions you will get the answers. Okay, then next after that state function, path function. Okay, then next we have moved for thermodynamic processes, isothermal process, adiabatic process. Like this we have discussed. Then next we have moved slowly to the first law of thermodynamics. What is that? du equals to dq plus dw. Okay, then after discussing this sign convention also, like dw, like work is done by the system, so it should be negative. Work is done on the system. See, whenever work is done by the system, then heat will be, see, work is done by the system now, it means system is doing some work on the surroundings. So during that process heat will be absorbed by the system. It means if it is positive, this will be, heat will be, see if I am saying isothermal process means what ma? What is constant? Temperature is constant. Change in temperature will be 0. So change in temperature is 0. Similarly, if temperature is constant, what about internal energy? Internal energy proportional to T I am saying. So if change in temperature is 0, see, T is constant, change in temperature will be 0. If T constant, U also constant. So then its derivation will be like difference will be 0. So this term becomes 0. If this is becoming 0, one term can send this side. So what happens now? dq equals to minus dw plus dq equals to minus dw. It means whatever the amount of heat absorbed by the system is used for work done on the surroundings. If it is absorbing some 5 joules of heat, okay, now how much amount of work will be done? Minus 5. What will be your answer? Like minus 5 is the work done by that system. Okay, like that you can answer. Okay, so in the same way you have one question in your module. You just try after the class. Okay, so just go through the questions, and if you have any doubts you ask me during the study hours, or whenever you find time you come and ask. Okay, then next after this what we discussed, let us conclude all the formulas. First law is over. Then next we slowly moved for isothermal process, like work done in isothermal process. What is that? W equals to minus 2.303 nRT log V2 by V1. In terms of pressures, 303 nRT log P1 by P2. And before this we have discussed about enthalpy and internal energy. Enthalpy equals to, change in enthalpy equals to change in internal energy plus PdV. Like this we have discussed. Okay, so you can also write, this as delta H equals to delta U. See, PV means what? Ideal gas. We have now PV equals to nRT. So from this, here I am writing differentiation, means here also I can write. So this is delta N, ideal gases now. So delta Ng RT. So this is the relation between enthalpy and internal energy. Okay, so how can we do this? Again, if I am giving a question like this, see, C plus O2 gives rise to CO2, I am saying. For this reaction, what is C plus O2 gives rise to CO2, I am saying. For this reaction, what is the relation between delta H and delta U, I am asking. How can you do this? Tell me. See, number of gaseous products minus number of gaseous reactants. So first balance the equation. See here, carbon, how many carbons are there? 1. Product side also should be 1 carbon. So 1, it is over. How many oxygens are there here? 2. Here also 2. It means 1 into 2 is 2 oxygen. That's it. So balanced. What about the physical state of carbon? It is solid, liquid or gas? Carbon, graphite form. What is the standard state of carbon? Graphite form. So that is, graphite is nothing but your pencil lid is there now. So it's solid only now. Yeah, like that. Next, what about this? What about this? Gas. Now delta Ng, how can you do this? summation of gaseous products minus gaseous reactants. How many are there products? 1. Reactants are how many? Gaseous reactants are how many? 1 minus 1 is 0. Therefore what happens? Delta H equals to delta U. Okay, like this they will ask what is the relation between delta H and delta U for a particular reaction. Okay, right. Or they will give 4 reactions, for which are the following reaction delta H is equals to delta U. Like that they make the question. You got now how to do this type of questions? Done. Next, after this I have told you about heat capacity also. Heat capacity like CV equals to N, like internal energy and CV relation, like du equals to N CV dt. Similarly dH equals to N Cp dt. Okay, now this is about isothermal, this is about isothermal work done. Okay, similarly adiabatic work done also there. What is that? Adiabatic work done. So all these formulas are from a previous class discussion only. Okay, so adiabatic work done means see du equals to dq plus dw. So what is this equation? First law. So but adiabatic means what is 0 here? See, adiabatic means this is a system, there is no exchange of heat between system and surroundings. So Q constant, therefore change in Q will be dq will be 0. So this term becomes 0 in which process? If this is 0, then whatever the internal energy that is used for work done, du equals to dw. Okay, so now simply you can say dw means, see from here dw equals to du. So du, that is nothing but NCV dt formula you can use for work done. Okay, so now what is this dt means? CV T2 minus T1. Okay, next what about the Cp CV relation? Cp minus Cv equals to R. Okay, so now we got something like Poisson's ratio. What is that Poisson's ratio? Cp by Cv. So I am dividing the equation with a Cv. So what happens? Cp by Cv minus Cv by Cv means 1, which is equals to R by what? Cv. Okay, from this I am writing Cv equals to R. Cp by Cv means what is the new term I am saying? Gamma. Gamma, Poisson's ratio, Cp by Cv. Okay, so here can I put gamma, like gamma minus 1 only. So if you bring this here, can we write like this? Yeah. So here you can include N in the place of Cv. What I can write? R by gamma minus 1 T2 minus T1. So this is the work done for adiabatic process. Okay. Now gamma values I told you for monoatomic, diatomic, polyatomic in the last class. Tell me what are those? So for monoatomic gas 1.66. For diatomic gas 1.4. Like polyatomic gas 1.33. Okay, remember these values. Same you are going to use in your kinetic gas, like KTG is there in your physics. There you will be using. Okay, next. So some other relations for adiabatic processes, PV power gamma equals to constant. Just remember this. This is also one more equation for adiabatic process. Okay, so these are all the formulas, and we have did few questions related to this. So the next topic I have started discussing about heat change during a reaction. It means enthalpy change, like delta H reaction. Enthalpy change during a reaction we are started discussing. It means what is enthalpy change means? For example, H2 plus Cl2 combining to form HCl. Okay, so I am saying here one HCl is formed means try to balance this equation. See here I want only one HCl. It means this should be half, this should be also half. So now what I am saying is enthalpy of formation. What I am saying? Enthalpy of formation. Means what is forming here? HCl. So when I use the word enthalpy of formation, please try to listen these 2-3 statements, then you can solve the questions easily. Enthalpy of formation means 1 mole of that substance is produced here from their elemental, like elements. See, what are the elements here we have? H means H2, Cl means, like what is the standard state of hydrogen? In nature, how it will be? H2 gas, H2 gas. And what about Cl? Cl2 gas. So when I say like enthalpy of formation of a product, it means that product is formed this side. How many moles it should be? 1 mole. So 1 mole of that substance is formed here from their elements. What are the elements here? Hydrogen and chlorine. So if I ask you to write enthalpy of reaction, so how you will be writing? So what is forming here? This is forming now. So enthalpy of formation of product, that is HCl minus, these are forming or deforming? So that's why I am using minus symbol. If one more also formed, what I should write? Place that whatever the thing is formed. Okay, but these are deforming now. So what I should use here? Enthalpy of minus enthalpy of formation of that is what? See, if it is forming, I should use plus symbol. But is this forming or deforming? That's why I am using minus. So what is this? H2. How many moles it is involved here? So you write here half. Okay, plus, see this is completely like minus symbol belongs to both of these. Half into delta H formation of Cl2. Is this clear? Okay. So now simply we can write enthalpy of formation of products minus enthalpy of formation of reactants. See, if multiple things are there, we are adding them. So summation of enthalpy of formation of products minus summation of enthalpy of formation of reactants. Okay. So now I will give you some question, I mean 1 or 2 questions, then you will feel more comfortable. So before going to that, just try to read these statements once. What this line says, once read it. What do we mean by enthalpy of formation? It is a heat absorbed or released when 1 mole of a compound is formed from its constituent elements. In the previous case HCl, what are the constituent elements? So it is forming from their constituent elements now under their standard elemental forms. What are the standard elemental forms? H2 gas, Cl2 gas. That should be in the standard elemental forms only. Okay, then only we can say it is enthalpy of formation. Then next, enthalpy of formation of the following substances are taken to be 0 under 1 bar and 298 Kelvin. It means at room temperature, at room conditions. What are the things you need to consider? See, oxygen at room condition, how it will exist? O2 in the gaseous state, right now. So since it is existing as O2 in the gaseous state, see in the nature, are you preparing oxygen? It is existing naturally now. So enthalpy of formation of O2 will be taken as 0. Enthalpy of standard enthalpy of oxygen is taken as how much? Similarly, are you preparing H2 in the like atmosphere, like in the nature? No, it is existing now. So at room temperature, at this condition, at 1 bar pressure and 298 Kelvin, so H2 how it is existing? H2 gaseous state. So enthalpy of formation for this standard enthalpy of formation of this also taken to be 0. Similarly, if you take H2 is over. See, chlorine also exists in which form? Gaseous state. So for this also enthalpy of formation will be, standard enthalpy of formation will be 0. Okay. So now instead of writing here gas, I am writing chlorine liquid. Enthalpy of formation will be how much I am asking. Will it be 0 or not? It will not be 0. Why it will not be 0? See, at this condition at 298 Kelvin and 1 bar pressure, that is what standard temperature and pressure. So at that values, how this chlorine exists? Gaseous state or liquid state? So gaseous state now, chlorine will be in the gaseous state. So in the gaseous state only it will be 0. If I mention liquid state, it doesn't equals to, it won't be equals to 0. Okay. Now see here. If I write enthalpy formation of graphite, carbon is there now. So carbon has graphite form. This is like, see, graphite Graphite will be in liquid state, gaseous state, what is it? Solid. Solid. So it will be taken as 0. But what about diamond form? It will not be equals to, it will not be equals to 0, because we need to take most stable form of it. What is the most stable form of carbon? Graphite form. Okay, right. Next, if I consider fluorine, what are the halogens, you tell me? Fluorine, chlorine, bromine, like this I am taking. See, at this temperature, at this standard conditions, enthalpy of formation of F2 will be, see, F2 will be in the gaseous state. Okay, it will be also 0. And chlorine also in the gaseous state. This will be also 0. But at these conditions, like at room temperature, bromine will be in the liquid state. Which is liquid state? Bromine will be liquid state. So its enthalpy of formation, standard enthalpy of formation, if I mention this as gaseous state, will it be equals to 0 or not? It will not be equals to 0. But if I mention it liquid state, equals to 0. Do you got what do we mean by this line saying here? Okay. So any element in its most stable state, in its standard phase, physical state, its enthalpy of formation will be 0. Okay, standard enthalpy of formation will be 0. Means you will get more clarity. Wait, 1 or 2 questions if we do. Read this question ma once. What they are saying? If, are you able to see from last bench? Read it now. If a standard enthalpy of formation of H2O2 and H2O are minus 88 and minus 286 kilojoule per mole, what will be the enthalpy change for the given reaction? Okay, so now what is forming, what is deforming here? H2O is forming and H2O2 is deforming. So what is the data provided? Did they provided formation enthalpies or combustion enthalpies? So who is forms here? Product will be forming. So enthalpy of formation of products minus enthalpy of formation of reactant should be taken. See, enthalpy of reaction they are asking now. So what you will write here? Enthalpy of reaction is equals to, tell me, enthalpy of reaction equals to enthalpy of products, formation of products minus enthalpy of formation of reactants. Everyone clear up to here? Okay. So now what is the product forming here? So you just write it as 2H2O. Like anyways it is formation only. Like for your clarity purpose I am writing. Now what is the standard enthalpy of O2? Gaseous state means it will be 0. So no need to bother about that. Okay, this is products over. Minus reactants. 2 H2O. 2. Okay. So do this. 2 into, for 1 H2O how much? Second value. Minus 6 plus this one. 2 into minus 188. So just solve this ones. What is your answer? 2, 1, 6, 7, 5. Okay, next this one. How much it is? Let's check. 576 minus 370, 572. So it is 6, 9, 1. So minus 196. We have first option now. So that is your answer. You got everyone how we are solving this question? Is this clear or not? Okay. Please tell me if there is any confusion. Now itself you ask. Yes, no. How no? If you take bromine, if you observe bromine at that standard conditions, it will be in the liquid state. In the nature. Once read this question. Everyone, please, fast. Remote. Okay, tell me, how can you answer this? Yeah, answer me fast. How to do this? The formation enthalpy of CO2, CO and H2 are given like this. Then the standard enthalpy change for the reaction. So how to do this, tell me? Standard enthalpy change. Delta H reaction is equals to, what to write? What is the data provided? Enthalpy of formations or combustions? Formations. So first, who is forming here? Products. So enthalpy of products minus enthalpy formation of products minus enthalpy formation of reactants, summation. So now what they are saying, see, H2 gaseous state it is there now, so its standard enthalpy of formation will be 0. So now no need to worry, these values are mentioned, just substitute them here. How much for CO? Like 1 CO plus 1 H2O minus 1 CO2. That's it now. Okay, so now what is the value of CO? Second one, minus 110.5. Next, minus 393.5. This one, see, H2O now. What is the value for H2O mentioned? 1, 2, 3, third one, minus 241.8. This one, minus of CO2 is how much? Minus 393.5. Yeah, just simplify this. So your answer will be with minus 41 or plus 41? One stick. See, 8 plus 3, 13. 1, 2, 5. Okay, plus only. 393.5. So what is your answer? 41.2. See, this is bigger number now. So plus. Everyone got this? Okay. So till now you have studied about enthalpy of formation type. Next one is enthalpy of combustion. What is it? Enthalpy of combustion. See, when I say enthalpy of formation, that substance will be presented product side of how much quantity? 1 mole of that substance presented the product side. Enthalpy of formation means. Similarly, if I say enthalpy of combustion, 1 mole of that substance is presented reactant side. When I say combustion, reactants giving rise to products. See, combustion means what? These reactant molecules will undergo combustion and gives you products. For example, methane I am saying. So who is undergoing combustion here? Reactant, like methane only now. So 1 mole of that reactant, 1 mole of that substance should be presented reactant side. Okay. So now read this once again definition. It is the amount of heat released when 1 mole of substance undergoes combustion in presence of oxygen. So for combustion purpose, definitely we require oxygen. Okay, so you can say complete oxidation also here. So for example, methane complete combustion produces how much energy? Minus 890 kilojoule per mole. So 1 mole of methane produces how much energy, ma? Now one question I can make here. 1 mole of methane means how many grams it is? What is the molar mass? 16 grams. So 16 grams is producing how much energy? So minus 890, like 890 amount like kilojoules of energy is produced. Now I am giving you only 4 grams of methane. How much I am giving you? 4 grams of methane. How much energy is produced? Upon combustion of 4 grams of methane, how many kilojoules of energy is produced? See, 1 mole is producing 890. 1 mole of methane is nothing but 16 grams. Okay, so 4 grams means how much? 4 grams means X. So use the unitary method. X will be 890 into 4 by 16. So this will be 4 times, this will be 222. 2. Okay. So that is how you need to solve the question. Do you got what I am discussing here? First model question is this one. Next one. See, if I want to write enthalpy of combustion or enthalpy of reaction for that, how can I write? Enthalpy of reaction. How to write this enthalpy of reaction for combustion data? Who is undergoing combustion? So enthalpy of combustion of reactants minus enthalpy of combustion of products. So there should be summation like this. Okay, if I want to write for this equation, you tell me fast. How to write this? Enthalpy of combustion of methane plus O2 0 it will be, don't consider that. Okay, minus enthalpy of combustion of CO2 plus enthalpy of combustion of 2H2, 2 into enthalpy of combustion of 2H2. So upon simplifying you will get the answer. Okay, now we will see one question, so that answer me first for this. The bond dissociation enthalpy is used to define enthalpy change of a reaction. See, bond dissociation, is it bond dissociation means breaking or making? So it means reactant side will break first, that will form product side. So what to take? Similar to combustion, what to take? Enthalpy of bond dissociation enthalpy of reactants minus bond dissociation enthalpy of products. So what is your answer? A. Okay, next. See here, this is the data provided. Enthalpy of reaction is how much? This much. How much? 1482 kilojoule. Then the bond dissociation energy of CH is this much, and bond dissociation enthalpy of CCl we need to find. So how can we answer this, tell me? C, H, Cl, Cl. This is the molecule they have provided. How it is converting, ma? 1 carbon atom, 2 hydrogen atoms plus 2 chlorines. So what we are making here? We are breaking this bond now. This side. Are we breaking this side any bond? Only here only now. So now delta H reaction is equals to bond dissociation if provided, what to take? Reactant side or product side? So delta H or the bond dissociation energy of what? Reactants. Reactants minus bond dissociation energy of products. Okay. So what are the bonds we are breaking at the reactant side? What are the bonds we are breaking? CH bonds. How many CH bonds? CH bonds how many? So you take 2 CH plus how many CCl bonds? 2 Cl. And this side, product side, any bond breaking we are making? No. So just take it 0. That's it, done. Enthalpy of this reaction is how much they are saying in the question? This value. 1482. Okay, so 1482 equals to 2 into CCH is how much? 415. Now what they are asking, 2CCl. See, except CCl bond energy, everything we have. So simplify it, you will get one of these options. 326. So upon simplifying, you will get 326. Once do it fast. Done? See, here I have 2, here also I have 2. Can I send this by 2? 7, 4, 1. Okay, which is equals to 415 plus CCl. So send this 415 also this side. 741 minus 415 equals to CCl energy. So how much it is? 11 minus 5, 6. 3 minus 1, 2. 7 minus 4, 3. Everyone got this? 326. Okay, next. Okay, next model question. Okay, let us finish this, come back. Read this question, ma. The second question. First one you already did. Enthalpy of combustion of carbon and carbon monoxide are given. The enthalpy of formation of carbon monoxide is, what is the data provided? Combustion. What they are asking us? Formation. See, formation, what to form here? Write that equation first. Carbon monoxide should be product side. Okay, so from where it is forming? From carbon. Carbon plus half O2 gives rise to CO. So this will be in the solid state. This is a gaseous state, like this you can write if you want. So delta H reaction, enthalpy of reaction. See, what do we mean by enthalpy of formation definition? Tell me. Definition. 1 mole of that substance should present at the, see, 1 mole of carbon monoxide is present at the product side. So for this reaction, what is the enthalpy change? This is the question they are asking now. Are you able to follow this up to here? Okay. So now this is fine. But data what they have provided? Combustion data provided. Who is undergoing combustion? Carbon. So enthalpy combustion of carbon, oxygen 0. For oxygen how much combustion or formation? That will be 0. This one is forming or undergoing combustion or formation? So that should be minus enthalpy of combustion of CO. So put the data provided here. How much it is? Carbon is how much? Minus 390. This is minus of minus plus 278. So upon simplifying, minus 112. So which is our answer? Option 3. Is this clear how we are doing? See, once again listen, I just wanted to repeat it. Question lo first data చూడండి. Data ఏమి ఇచ్చిన వాడు? Combustion data అని చెప్పింది. Okay, keep it aside. Next one, what they are asking? Formation of carbon monoxide. It means 1 mole of that product, 1 mole of carbon monoxide should be present at the product side. So write the reaction as per that. We have written 1 mole of carbon monoxide this side. So try to balance. If 1 mole of carbon monoxide ikkada ravalante, how many carbon should be there? Like that you balance properly. Here it should be, it must be how many moles? 1 mole. Ala ఉండేటట్టు balance చేయండి. చేసిన తర్వాత ఎంథాల్పీ ఆఫ్ రియాక్షన్ వీ నీడ్ టు క్యాలిక్యులేట్. రాసేసాం. రాసిన తర్వాత డేటా ఏమి ఇచ్చింది, కంబషన్ ఇచ్చింది కదా, విచ్ ఈస్ అండర్ గోయింగ్ కంబషన్. You write here first. This is forming now, CO. So combustion and formation with opposite sign. That's why we are taking minus product one, whatever it is mentioned. Is this clear or not? Okay. Next question. Answer me this. How to do this, tell me once again. See what the data provided, formations. Formation means product minus, that's it. Do it and tell me. Everyone once try and tell me. Minus 200 or plus 200? Don't think about other answers. పక్కలను పట్టించుకోకండి, మీకు ఏది వచ్చిందో అది చెప్పండి అంతే. ఓకే, సో లైక్ దట్ ఇట్ షుడ్ బి ఇన్ ద క్లాస్. ఓకే, సో ఎంథాల్పీ ఆఫ్ రియాక్షన్. The values of heat of formation of SO2, SO3 are given, heat of formation of reaction. So who is forming in the reaction? Enthalpy of formation of SO3 minus enthalpy of formation of SO2. For oxygen it will be 0. So for SO3 how much? Minus 198.2. This is minus of minus now. So minus of minus becomes plus. So plus 398.2 minus 198.2. Plus 200 kilojoules. Okay. So next one is what? Enthalpy of sublimation. What do we mean by sublimation? If a substance like a solid is directly converting into that process is called sublimation. Some examples here for sublimation is dry ice. Solid CO2 is called dry ice. Naphthalene is also one example. Camphor you know now, that is also one example which convert directly from solid to gas. Okay, see here 1 mole of that substance directly converting from solid to its gas. During this transformation, whatever the enthalpy change is there, that is called enthalpy of sublimation. See 1 mole of that CO2 converting into its gaseous solid to gas. So heat associated during this process is called enthalpy of sublimation. That's it. Okay, next one, what is this Hess law? Much familiar, I think everyone is familiar with this. 2 marks question, 4 marks question. Yeah, tell me. See whether a reaction is taking place in single step, multiple step. Whatever the heat associated will be same whether it is in single step or multiple step. So here formation of CO2 happening from carbon in single step. Let us say this is enthalpy change is delta H. Okay, now same formation of CO2 taking place in multiple step. First step is formation of carbon monoxide. For the carbon monoxide again I am adding oxygen giving so this is for step 1 delta H1, step 2 delta H2. That is nothing but delta H1 plus delta H2. Like this you got this. Okay, next you try this question once and tell me what is your answer. Fast. For a given reaction, A to D is a reaction. So that A to D is taking in multiple steps like A to B first, B to C, C to D. Now do the question then. 1? Yes. Everyone 1? So how to do this? See, A to D is the final first reaction, like single step reaction. It means that delta H for A to D is equals to A to B delta H1 plus delta H2 plus delta H3. So for delta H they are saying it as X is equals to H1 is how much? X1. H2 is, we need to calculate. H3 is X3. Now I want H2 means X minus of these two things, minus of X1 plus. That's it now everyone? Yeah, next. Okay. So similar to this, we have see, heat of formation over, heat of combustion over, okay, heat of sublimation also over, next heat of neutralization or enthalpy of neutralization. So what do we mean by enthalpy of neutralization? See, if you have a strong acid and strong base, see, strong acid means what it will provide? H plus, and base means it will provide OH minus. Okay, if a neutralization is reaction is taking place between a strong acid and a strong base, during that process some amount of energy is released. That energy is fixed. How much energy it is? Minus 57.3 kilojoule per mole. So if 1 mole of that reaction is taking place, how much energy is released? Minus 57.3. Okay, so now when it is happening, neutralization between what? Between a strong acid and a strong base. Give one example, like NaOH plus HCl. If the neutralization is taking place between them, then what is the heat of neutralization? How much energy is released? So when acid base reaction taking place, what we are going to get? Salt plus water. This you know. Okay. Now instead of taking strong acid and a strong base, I am taking one weak base plus strong acid. Will the same amount of energy is released? No. Why no? Because here NaOH releases OH ion easily, but here NH4OH is a weak base now, it won't give OH minus as like NaOH. That's why some amount of energy is utilized by NaOH. Instead of releasing 57.3, now the amount of energy released might be some 54 or some 55, depending upon what type of acid or a base you are using. So where do we have maximum amount of energy released? And minimum amount of energy released? Weak acid and weak base. If both of them are weak, it will be least, na? You got this concept? Yeah, that's it. Next. Sometimes if you add some salt to the water, during that process, if you touch the beaker, you might feel hot or you might feel cold. So it means, read this, the heat released or absorbed when 1 mole of a compound is dissolved in excess of solvent. Okay, so whatever the heat released during that process is called enthalpy of solution. Okay, fine. See, you know copper sulfate. So copper sulfate anhydrous form, if you observe, it has no color, like white color you can say. But if you add a little amount of water, it will become copper sulfate dot 5H2O. See, you are adding not excess amount of water, you are adding limited amount of water, like 5H2O only we have added. So this process is called enthalpy of hydration. If I say excess amount of water, that is called enthalpy of solution. So you got the difference. Enthalpy of hydration means limited, some quantified amount. Solution means excess. Okay. So during that process, for every 1 mole, how much energy is released? That is called enthalpy of hydration. Here it is enthalpy of solution. Okay, that's it. Yeah, we'll do few more questions. Yeah. Next one is entropy. Have you heard this word entropy? Yes. See, if you observe in the nature, some process happens on their own naturally. For example, flow of water from hilly areas to down. Are we using any machines there? No, it is happening naturally. But reverse to that process? So that coming from up to low, that hilly region to lower region, so it is a spontaneous process. Okay, but reverse is a non-spontaneous, you should say. So every spontaneous process, during any spontaneous process, entropy will be increases. What do we mean by entropy here? The randomness or the disorderness of that system. Okay, so you just read entropy is a measure of degree of randomness or disorderness in a system. So entropy is also an extensive property and it is a state function. Okay. So in the classroom also, let us say one funny example you can take. So if I go out, if a teacher goes out, classroom become full disorder, like shouting, sitting here and there, jumping here and there. This is a natural process. Disorderness increases or decreases? Increases. But if teacher comes and saying everyone to be silent, this is non-spontaneous. See, I'm using my energy. Like a machine, I am spending some energy here so that this process is taking place. Okay, you can understand in the simple way. Okay, right. So now, what this second law of thermodynamics says is, yesterday we have studied first law of thermodynamics. There I told you that law of conservation of energy. The total energy of universe remains constant. But when I say about second law of thermodynamics, the total entropy of universe always tends to maximum. So see, it states that the entropy of universe always increases in every spontaneous or natural change. Okay. So what is the second law of thermodynamics? The entropy of universe always tends to maximum, like increases you should say. Okay. See, if I say increases, that should be indicated with delta S positive. Decreases means delta S. See, this is greater than 0 or less than 0. So entropy increases here, it indicates. In this, for a spontaneous process, delta S will be positive, I can say, or increases, I can say. Okay. So if I come to the class and I am saying you to be silent, sit here, for each bench 4 members, all these are becoming order, a disorder becoming order. So it's a spontaneous and non-spontaneous? Non-spontaneous. So non-spontaneous process, entropy will be decreases, like disorderness will be decreases. Everyone sitting in order now? So entropy will be decreases. So that you should write it as less than 0, or entropy will be like delta S will be negative. Negative means less than 0, like same meaning now. So here it should be delta S should be positive. So read this statement once again. So in a natural process, entropy what happens? So delta S for the natural process will be positive, greater than 0. Okay. Now read the statements once. In which the entropy is negative, they are saying. See, a solid, H2O solid I have, H2O liquid I have, H2O gas. So where do we have maximum randomness? Gas. Because here particles are having most kinetic energy, they will move here and there randomly. So the randomness will be maximum in? So entropy gaseous will be greater than entropy liquid, least is entropy solid. Is this clear or not, everyone? Okay. So evaporation of water, it means liquid converting into vapors. So entropy what happens? So here delta S is positive. Okay, next this one, expansion of gas at constant temperature. See, initially in small volume gaseous particles are there. Now big volume. What happens? Their mobility increases, randomness increases or decreases? So here also positive. Next, this one, sublimation of solid to gas. Sublimation means what? What happens to entropy? So here also delta S. Now see here, during this reaction 2H gas particles converting into H2. See, this is also gas. See, how many moles of gaseous products are there? How many moles of gaseous reactants are there? So number increasing or decreasing? So what happens to entropy? Gaseous particles decreasing now, so entropy also? See, when you calculate delta Ng for a reaction, if it is greater than 0, it is delta S also greater than 0. You can say it is a spontaneous process. Or delta S will be greater than 0. See, here how many gas particles are there? Ma, this side. One gas particle, but here how many are there? So 1 minus 2 means negative value you are getting now. It means number of particles decreasing means entropy also. Is this clear or not? Yeah. So tell me for this reaction, N2 plus 3H2 gives rise to 2NH3. What happens to delta S? 2 minus, all of these are gases only now. Consider gases only, not solids or liquids. So 2 minus 4. So how much? Delta Ng is minus 2, then delta S also negative, that is decreases entropy. Is this clear how to identify? So negative in which case for the 4 options? Only 4th option. Clear na everyone? Okay. Okay. Now you want mathematical equation for calculating entropy. So this is theoretical understanding of entropy. Next one is what? Mathematical equation. Like delta S is equals to heat supplied dQ by temperature. So dQ by T. Change in heat by temperature. This gives you entropy change. Okay, write this. This is the mathematical equation for entropy. Okay. Okay. So once read this question. Calculate the entropy change when 2.8 grams of N2 gas expands thermally, isothermally, reversibly from an initial volume of 1 liter to 10 liters at 27 degrees Celsius. So how can you solve this? How can you solve this? Tell me. Yeah. So what is the formula given you? dQ by T. Okay. So what process they are saying? So can I say dQT? It means isothermal process, heat change. So isothermal process means what we discussed, du equals to dQ plus dW. Isothermal process means what is 0 here? du is 0. So if it is 0, dQ equals to minus. What is the formula for dW for isothermal reversible process? That one. So minus 2.303 nRT log V2 by V1. So same formula I can use here also. See, du dW are equal. So I am using this here as 2.303. See, minus I am not taking. Why? See, minus of minus becomes plus. Okay. So 2.303 nRT log V2 by or P1 by P2 also you can take by T. See this temperature, this 2 can I remove? So what is the final output? 3.303 nR log V2 by V1. Okay. So try to substitute the data provided. what they are saying, 2.8 grams. 2.303 into number of moles, how much? 2.8 by 28. What about R? How much we should take? Joules now. So what is that? 8 point joule, Kelvin inverse, mole inverse you can take, into log V2 is 10, 1. So this is log 10 is 1. So upon simplifying, see, this is 2.8 by 28 means 10. Okay. Now remember here, what are the data here? I have 2.303 into R, 8.314 is there now. So upon simplifying this, you are going to get 19.11. How much? 19.11. Okay. So 19, see this one into this one. It's a constant values now, you just multiply, you will get this number. Okay. So why I am writing them separately? Whenever you are doing, you will be seeing most commonly this data. So you just remember 2.303 into 8.314 around 19.11. Okay. So 19.11 into 1 by 10 joules per Kelvin. Per Kelvin. Yeah. So what is your answer? 1.9 joule per Kelvin. So what is your answer? Second option. Is this clear everyone what we are doing? So what is the formula to use for calculating entropy at constant temperature? dq by t means what I can write, integral equation 2.303 nr log V2 by, see for isothermal work done we are saying 2.303 nRT now, just remove the t and use here, that's it. Okay. So along with this some other formulas, see, solid converting into liquid, what is this process called? Fusion. What is it? Fusion. So whatever the energy change during this process is called enthalpy of fusion. What is it? Enthalpy of fusion. So now if I ask what is the entropy here, there should be entropy of that fusion I can say. Okay. So entropy of fusion is nothing but, see, H is what? Heat only now, enthalpy or heat energy. So instead of writing dq, what I am writing? dH fusion by temperature. So dH fusion by that temperature we used for this fusion purpose. Okay. Similarly, enthalpy of vaporization means, like entropy of vaporization means, you should say enthalpy of vaporization by T vaporization. T vaporization is nothing but liquid converting into vapors. So at what temperature it happens? Like for water it is 100 degrees. Like I can say simply boiling point of that liquid. T boiling. Okay. So you can write this. Similarly, if I say entropy of sublimation, N is equals to enthalpy of sublimation by T sublimation. Write these two formulas. .5 times. So first option is your answer.